Fiber IP-20N radio frequency units. In this module we will introduce the radio frequency units options to be used with the Fiber IP-20N, focusing on the legacy IF cable connected ones. The agenda of this module covers the following topics: radio frequency units for IP-20N with IF cable, RFU selection guide, depending on the configuration and customer needs, recommended IF cables, RFU-C option, 1500 HP, RFU HP options, with split mount configuration and branching, new outdoor circulator block, called OCB, split mount configurations, indoor configurations and green mode. The Fiber IP-20N can work with two lineups of radio frequency units. The IF-based ones, with the established radio modem cards and RFU-C or RFU high power, and the all-new lineup of products that come to work with a new radio interface card. For the new RF interface, the IP-20N utilizes a new radio interface and card. The modulation and demodulation part, as well as the raising into frequency, is done with the help of the new radio units, who from now include the modems. The new radio units that can work with the RIC-D and the IP-20N are RFU-S, a single-core radio, RFU-D, dual-core radio, both in 6 to 42 GHz frequency range. Then we have the RFU-E for covering E-band and the RFU-D high power for covering long-haul needs, from 4 GHz to 11 GHz. All of these new radio units are connected to the IP-20N with the help of Cat5 or Cat6 Ethernet cable and RJ45 Ethernet plugs, and use a proprietary mechanism to feed signal and power over Ethernet through the electrical cable. All of the new radio units are only usable in conjunction with the RIC-D card set inside the IP-20N chassis. The radio frequency units generally provide the raising into frequency, from the intermediary frequency to the desired subband. The communication from the indoor unit to the radio frequency units are done through coaxial cable that allows the radio to be powered up and also fed digital signal. The IP-20N can support two different RFU connections, one through Ethernet cable and second one through coaxial cable that is part of this presentation, both of them with a single core radio. These products come with high order of modulation, up to 2048 QAM. RFU-C with standard power up to plus 24 decibels, and RFU-HP or 1500 H with ultra-high power up to plus 33 decibels, capable of serving the long-haul applications. In terms of frequencies, the RFU-C support the common 6 to 42 GHz, and the RFU-HP or 1500 HP with high power supports 6 to 11 GHz. For the standard power radio frequency units, it is recommended to use the split mount installation, where RFUs can be attached in direct manner to the antenna, or remote mount with a flexible waveguide between the mediation device and the antenna. The RFU-HP or 1500 HP can be mounted in either all indoor or split mount configurations. 1500 HP and RFU-HP1RX supports space diversity via baseband switching in the indoor unit, called BBS. The 1500 HP2RX supports space diversity through IF combining, called IFC. Both types of space diversity are valid solutions to deal with the presence of multipath propagation effects. The RFU-HP also includes a power-saving feature, called green mode, that we'll describe in the following slides. This enables the microwave system to automatically detect when link conditions allow it to use less power. The indoor unit and radio frequency units are connected by a coaxial cable with 50 ohms impedance, using an N-type male connector on the RFU side, and TNC connector on the radio modem card side, in the chassis. This is another way to look at the RFU selection guide, depending on the possible configurations. This table presents the list of configurations available per each type of RFU. Note: remote mount configuration is not supported for 42 GHz. RFUC and RFUHP 1500 HP RFUs are connected to the RMC by a coaxial cable with 50 ohms impedance and can reach up to 300 meters depending of the model of utilized cable, with an N-type connector, male, on the RFU side and a TNC connector on the RMC side, in the IP-20N chassis. The RFUC Fiber RFUC is a fully software configurable state-of-the-art RFU that supports a broad range of capacities from 10 megabits per second up to 500 megabits per second. RFUC operates in the frequency range of 6 to 42 GHz. RFUC supports low to high capacities. With RFUC, traffic capacity, throughput and spectral efficiency are optimized with the desired channel bandwidth. For maximum user choice flexibility, channel bandwidths from 3.5 to 56 MHz can be selected together with a range of modulations. RFUC provides a range of modulations from QPSK to 2048 cam. When RFUC operates in co-channel dual polarization, CCDP mode, using XPIC, two carrier signals can be transmitted over a single channel, using vertical and horizontal polarization. This enables double capacity in the same spectrum bandwidth. Note that remote mount for 42 GHz is not supported. The RFUC radio supports the same antenna interface and the same mediation devices as RFUS. In this scenario, you can see the RFUC in a 1+0 and 2+0 single or dual polarization configuration, with a direct mount to the antenna. The main difference between coupler and splitter is that the coupler adds to the secondary path 6 dB of attenuation. In direct mount, the polarization is changed by turning 90 degrees both feed horn or antenna and RFU as well. In direct mount configurations, the polarization is dictated by the antenna interface in the mediation device. Please refer to the installation guide where you can find explained the procedure for changing the polarization. The RFUHP 1500 HP, Fiber 1500 HP and RFUHP are high transmit power RFUs designed for long-haul applications with multiple carrier traffic. Together with their unique branching design, 1500 HP, RFUHP can chain up to 5 carriers per single antenna port and 10 carriers for dual port, making them ideal for trunk or multi-carrier applications. The 1500 HP, RFUHP can be installed in either indoor or split mount configurations. The RFUHP also includes a power-saving feature, called green mode, that enables the microwave system to automatically detect when link conditions allow it to use less power. 1500 HP and RFUHP1RX supports space diversity via baseband switching in the IDU, called BBS. The 1500 HP2RX supports space diversity through IF combining, called IFC. Both types of space diversity are valid solutions to deal with the presence of multipath. 1500 HP RFUHP provide a range of modulations from QPSK to 2048 cam. Note that the main differences between the 1500 HP1RX and RFUHP1RX are: the RFUHP offers full support for 3.5 to 56 MHz channels and the RFUHP supports the green mode feature. Note that NEBS, Network Equipment Building Standard, Level 3 has strict specifications for fire suppression, thermal margin testing, vibration resistance, such as earthquakes, airflow patterns, acoustic limits, failover and partial operational requirements, such as chassis fan failures, failure severity levels, RF emissions and tolerances, and testing and certification requirements. 1500 HP, RFUHP functional block diagram and concept of operation. The RFU handles RF signal processing. The RFU encompasses the RF transmitter and receiver with all their related functions. The 1500 HP RFU HP product line was designed to answer the need for a high-power RF module together with IF combining functionality and the ability to concatenate several carriers with minimal RF branching loss. Each of these RFU types must be connected to an OCB, outdoor circulator block, which serves as both an arrow duplexer and a mediation device to facilitate antenna connection. This comparison table summarizes the differences between the RFU HP and the 1500 HP with 2 RX or 1 RX. Split mount configuration and branching RFU HP and RFU 1500 HP. Branching network. The 1500 HP RFU HP radios can be installed either in split mount or in all indoor configurations. Both systems are fully compatible with all OCB and ICB devices. Please note the following abbreviations. OCB means outdoor circulator block, ICB means indoor circulator block, and ICC means indoor combiner circulator. The outdoor circulator box, OCB. Split mount configuration and branching network. For multiple carriers, up to 5 carriers can be cascaded and circulated together to the antenna port. Branching networks are the units which perform this function and route the signals from the RFUs to the antenna. The branching network can contain multiple OCBs. When using a split mount or all-indoor compact, horizontal configuration, the OCB branching network is used. In the OCB, the TX and the RX path circulate together to the main OCB port. When chaining multiple OCBs, each TX signal is chained to the OCB RX signal and so on, using S-bend section. The OCB, outdoor circulator block, has the following main purposes: hosts the circulators and the attached filters, routes the RF signal in the correct direction, through the filters and circulators, enables RFU connection to the main and diversity antennas. Fiber 1500 HP and RFU HP supports 2 types of OCBs, OCB, older type, and OCB, current type. The OCB is optimized for configurations that do not use IFC space diversity. To support IFC space diversity, a diversity block is added. The OCB has only one type, and can be connected to an antenna via a flexible waveguide. The OCB connection is at the rear of the OCB. It includes proprietary accessories. Each OCB has 3 ports. The in-out port is located at the rear of the OCB for antenna connection, expansion port for chain an additional OCB, and diversity port. If the system is not configured for diversity, all the relevant ports on the OCB must be terminated using waveguide shorts. Unused expansion ports are terminated with a waveguide termination. OCB components include the following. Specific frequency channels and TX, RF separation. The filters are attached to the OCB, and each RFU contains 1 RX and 1 TX filter. In an IFC space diversity configuration, each RFU contains 2 RX filters, which combine the IF signals, and 1 TX filter. The filters can be replaced without removing the OCB. DCB, diversity circulator block. The DCB is an external block which is added for IFC space diversity configurations. The DCB is connected to the diversity port and can chain 2 OCBs. Asymmetrical coupler kit for 1+1 hot standby, HSB, configurations. Symmetrical coupler kit used for adjacent channel configurations or 1+1 HSB with symmetrical losses. The U-bend connects the chained DCB, diversity circulator block, in N+1/N+0 configurations. The S-bend connects the chained OCB, outdoor circulator block, in N+1/N+0 configurations. And the pole mount kit. The pole mount kit can attach up to 5 OCBs and the RFUs to the pole. The kit enables fast and easy pole mount installation. Let's have a look in some of the mentioned configurations where it's possible to observe the OCB interconnection, 1+1 HSB and 2+2 HSB with XPIC, 1+1 HSB with SD and 2+2 HSB with SD and XPIC, 3+1 or 4+0 and 4+1 or 5+0 single polarization, 1+0 SD. 1+1 or 2+0 SD and 2+1 or 3+0 SD single polarization. As was explained in previous slides, the expansion of the systems depends on the utilized components. The protection features are configured in the IP-20 terminal. In this image you can see a system with 4 RFU HP, 1500 HP with, and without space diversity. Note the highlighted interconnection components, S-band, U-band and DCB components. All indoor configuration. When using an all-indoor configuration, 2 variants are available. Horizontal configuration, for minimal rack space usage, with OCB that can be installed in a 19 inches rack, open rack, frame rack, in a horizontal position. Vertical configuration, where the ICB, indoor circulator block, branching network is used. The main differences in branching concept between the OCB and the ICB relate to how the signals are circulated. OCB as was explained in previous slides. ICB-all the TX signals are chained together to one TX port, at the ICC, and all the RX signals are chained together to one RX port, at the ICC. The ICC circulates all the TX and the RX signals to one antenna port located in the top of the rack. When RFU HP, 1500 HP is installed in an all-indoor configuration, there are several installation options. In ETC or 19 inches rack, up to 5 radio carriers per sub-rack for a total of 10 radio carriers per rack. Compact assembly as was mentioned in previous slide with up to 2 radio carriers in horizontal placement, without a sub-rack. In the screen you can see different configurations pointing the location of the ICC and the position of the antenna ports. Remember that, in ICB, all the TX signals are chained together to one TX port, at the ICC, and all the RX signals are chained together to one RX port, at the ICC. The ICC circulates all the TX and the RX signals to one antenna port located in the top of the rack. Green mode power consumption reduction for RFU HP1RX. The RFU HP also includes a power-saving feature, green mode, that enables the microwave system to automatically detect when link conditions allow it to use less power. Minimal power consumption is required in 99.9% of the time. Green mode enables the reduction of consumed power by automatically reducing power consumption according to the TX power, with no traffic impact. At different TX power levels a different current is required by amplifier. For instance, RFU HP radio operates in several fixed and predefined power consumption states. The transition between power states is hitless and errorless. High bias TX power greater than 28 dBm up to 31 dBm. Mid bias TX power 28 dBm greater than 22 dBm, and low bias TX power 22 dBm. In this screen you can observe that when bad weather conditions are present, the TX power increases and also the power consumption. When weather conditions improve as clear sky, the power transmission and power consumption are reduced. In the animated example we can see when the TX power increases, also the power consumption increases, depending of the transmit level utilized. In this module we discuss about radio frequency units for IP-20N with IF cable, RFU selection guide, depending of configuration and customer needs, recommended if cables, RFU C option, 1500 HP, RFUHP options, with split mount configuration and branching, new outdoor circulator block OCB, split mount configurations, indoor configurations, green mode. Thank you for your attention.